Hello, welcome to Zigmatech Learning Hub. I will be an instructor for chemistry. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, JCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Welcome once again. Today we are going to be talking about chemical formulae and equation, part 2. You know, we talked about the chemical symbols, formulae, and equation before now, and we are done with the symbols. But today's class, we are going to be looking at formulas and how to use them to solve equations. Now, by the end of this lesson, you should know what atomic mass and molecular mass is, how to calculate atomic mass and molecular masses, what is a mole, molar mass, and how to calculate them. First of all, let's look at what atomic mass is. Atomic mass is the total number of protons, neutrons, and electrons in a single atom when it's at rest. It has an SI unit of AMU. AMU means atomic mass unit, and a mass of 1.660539040 times 10 to the power negative 24 grams. This is the mass of an atom. Why? Because the atoms are very small. They are very small, so this is their mass. Okay. Now, the protons and the neutrons alone gives us the mass number. In essence, atomic mass is the total mass number and electrons in a single atom when that atom is at rest. You know, you can't calculate when an atom is moving, the calculation cannot be stable. Why? Because you cannot calculate correctly what is moving. You only calculate, any calculation you want to give must be calculated when it's at rest. In essence, when it is in a position. You can now calculate. Example, I want to calculate the work done of somebody. Okay? You calculate the distance he made. In essence, you calculate from point A to point B, from his kinetic energy to his potential energy. Now, like I said, the number of protons and neutrons make up the mass number. I've told you that before. So in essence, the atomic mass is the number of mass number and the electrons in a single atom when it's at rest. Now, what is atomic mass unit? Like I said at AMU, the atomic mass unit is still called the Dalton. It's still called the Dalton. It is defined as the mass exactly equal to 1/12 of the mass of one carbon-12 atom. And it has a mass number of 1.99236465547 times 10 to the power negative 23. Now, this is the unit of the atomic mass. This is the unit of the atomic mass. And I said MB, note that this mass is assigned to the atomic mass of 12 units. In essence, every 12 units of mass, every 12 times of the protons, neutrons, and electrons together gives you a mass of 1.99236465547 times 10 to the power negative 23. Every single 12 units of the atomic mass gives you this unit. Now, atomic weight. Atomic weight. Now, we talked about the mass. You know, we know from mass you can get weight. 10 grams of mass is equal to 0.1 Newton of weight. So now the total weight of the protons and the neutrons and the electrons is called atomic weight. When the mass is being gotten, the total weight of them is called the atomic weight. The atomic weight is the total weight of an atom. It is equal to the number of protons and neutrons with a little extra added by the electron. Why? Because the electron is outside the shell of an atom. So it is not really inside the shell. Remember, the protons and the neutrons are found in the nucleus of an atom. In essence, it is inside the atom. You understand? It is inside the atom. So now, when you want to calculate the weight, you calculate what is inside. The outer part is not really necessary. Let's take, for example, you want to calculate the weight of water. It is water inside that will be calculated correctly. The water that is being outside the bucket, those ones that drains outside the bucket cannot give you an exact weight, though it will be added because it is among what you're weighing. It will be added. It's among what you're weighing, but the issue is it will be very little to what is inside the bucket. So in that context, the weight of an atom is being calculated by the weight of the proton and the neutrons. In essence, with a little added electron. Like I said, the electron is at the outermost shell of the atom. It is always moving. It's constantly moving. So in essence, the calculation will not be straight if you want to calculate an electron. Why? Because it is constantly moving. So in essence, the total weight is the total mass number with a little added of electron. The total weight of an atom, atomic weight, is the total weight of the mass number with a little added of electron. If you cannot put your mind in this long definition, you just have to cut it short. Remember, it is the protons and neutrons that is being calculated mostly because it is found inside the atom. It is found at the center part of the atom, which is the nucleus, and the electron is the outermost shell. So in essence, the electron will not give much weight inside the atom. Now, differences between the atomic mass and the atomic weight. The atomic mass is the total mass of an atom, whereas the atomic weight is the weighted average of the naturally occurring isotopes. In essence, the atomic mass is just the mass of an atom. Okay? It's just the mass of the protons, neutrons, and the electrons, bringing them together. But the electrons is not really calculated. Why? Because it brings out a little. Okay? It brings out a little. So the mass number, like I said, is the total mass of the protons and the neutrons. The total mass of the protons and the neutrons found in the nucleus becomes the mass number. Like I said, because the electrons are not inside the atom. So they bring out very little or nothing. So they are irrelevant when it comes to the atomic mass. Now they say the atomic weight is weighted average. Now, the average weight, do you understand? The average weight of the full particles of an atom, okay, occurring in isotopes. Remember, I told you that isotopes are atoms that have the same atomic number but different mass number. In essence, the isotopes, the isotopes that are found in the atom becomes the atomic weight. Okay, becomes the atomic weight. Now, every mass number is basically times 2 of the atomic number. Every mass number is basically times 2 of the atomic number, apart from chlorine and some other elements. Apart from chlorine and some other elements. Chlorine has 2 isotopes. Chlorine has 2 isotopes. You know, isotopes of chlorine are this and this. In essence, they have the same atomic number, 1717, but they have 2 different mass numbers. They have the same atomic number, but they have 2 different mass numbers. As you can see. So chlorine is not a whole number. It has a mass number of 35.5. So it is not a whole number. Now, it is not a whole number because it is the average mass of all the isotopes. It is the average mass of all the isotopes. What do I mean? It is the average mass of 35 and 17, the average mass of 37 and 17. It is the average mass of all the isotopes. Every isotope's neat, it becomes average mass. Now, when the molecular formula is not a whole number, it becomes an isotopic mixture. Because chlorine, every reaction with chlorine is not a whole number. So when this molecular formula, when this molecular mass, okay, when this molecular mass is not a whole number, it becomes an isotopic mixture. In essence, an isotopic mixture is a process whereby the molecular mass of a substance is not a whole number. The molecular mass of a substance is not a whole number. So now, let us go to relative atomic mass and weight. Relative atomic mass and weight. You've known what an atomic mass is. You know what an atomic weight is. Okay? Now, there's a ratio. Okay? There's a ratio of every average. We know that ratios are mostly division. When I say 1:2, I mean 1/2. In essence, there's a ratio in this particular atomic mass and weight. Okay, when these ratios come together, they form the relative atomic mass and weight. And relative atomic mass and weight is the ratio of the average number of atoms of a chemical element in a given sample of the atomic constant. Is the ratio of the average number of atoms in a chemical element in a given sample of the atomic constant. Now let's take for example ratios. Okay? Take for example water. Now the ratio of hydrogen to oxygen is 2:1. Why? Because hydrogen is 2 and oxygen is 1. Now, atomic constant. In essence, this becomes a constant. Constant, it does not change. It is like that. Take water to anywhere, you still find 2 atoms of hydrogen, and you will still find 2 atoms of 1 atom of oxygen. So the ratio in a chemical element is given as a sample. Now, what is atomic constant? An atomic constant is defined as 1/12 of the mass of carbon-12. In essence, every carbon-12 divided by 12 divided by 1/12 gives you the atomic constant. The atomic constant. In essence, the atomic constant is 1/12 times minus 12. 1/12 times minus 12. Now let's take a quick question on this atomic mass, on this little atomic mass. Now they say, find the element. Find the elements. Question. Atomic mass. They say, find the elements. Find the elements mass number whose mass number, whose atomic number is 15, and the number of neutrons present is 15. Whose atomic number is 15? 15. And the number present. And the number present, okay, and the number of the neutrons present. And the number of the neutrons present is 15. Solution. It's a very simple thing. It's not a hard thing. Now they said find the element's mass number whose atomic number is 15 and the number of the neutrons present is 15. Remember I told you atomic number is the number of protons in an element. The number of protons in an element is the atomic number of that element. In essence, and it is how it is the law used in arranging the elements in the periodic table. So if the element, if let's say carbon is 6 in the periodic table, that means the number of protons in carbon is 6. That means the atomic number of carbon is 6. So any element you see in the arrangement, any element you find in the periodic table each number that you see it in becomes the atomic number, becomes the proton. So if hydrogen is 1, then number of protons of hydrogen is 1. If oxygen is the 8th element, then oxygen number of protons is 8. Now, we said the atomic number is the number of protons. Okay? And they say find the element's mass number. I told you mass number is the number of protons and neutrons in an atom, in an element. The number of protons and neutrons in an element or in an atom is called the mass number. So it's very simple. So the mass number, they say the atomic number is 15, and the number of the neutrons present is 15. So now, mass number is the number of mass number is equals to number of protons plus number of neutrons. Gives you the mass number. So in that sense, the atomic number, like I said, is the number of protons. I've told you that before. So in that sense, they said the number of protons, which is the atomic number, is 15. And the number of neutrons present is what? 15. So it will be 15 plus 15. In essence, the mass number is 30. So the mass number of this element is 30. You're done for that. Now, let's go to relative molecular mass. Relative molecular mass. Relative molecular mass is the sum of the relative atomic mass of all the atoms which are present in a given molecular compound. Like I said, mass numbers are basically twice the atomic number, apart from some element like magnesium, apart from some elements, like chlorine, elements like chlorine, which is not the whole number, 35.5, sodium, which is 23, and some other elements. So basically, the mass number, like I said, is times 2. So now, the relative molecular mass, okay? The relative molecular mass, remember, molecules, why it is called relative molecular mass, okay? It's because the atoms come together to form molecules. So when these atoms, when the mass of an atom come together and they form molecules, they become molecular mass. When the atoms come together, when the mass of atoms come together to form molecules, they become molecular mass. Remember, it is atoms, group of atoms that makes molecules. You know, molecules are a neutral group of atoms. We know that. So the relative molecular mass is the sum of the relative atomic mass of all the atoms which are present in a given molecule or compound. So the atomic mass of every element in a compound becomes the molecular mass. Now let's look at some questions related to relative molecular mass. Now, the question says, calculate the relative molecular mass of A subscript 2 SO4. Now, A subscript 2 SO4 is sulfuric acid. I call it sulfuric acid or tetraoxosulfate 6 acid. Anyone you like is correct. Now, remember, and they said, now you're working with the mass number. It says it's the relative atomic mass of all the atoms which are present in a given molecular compound. So you're working with the mass number, the sum of the relative atomic masses. In essence, you're adding together the sum of the relative atomic masses. You're adding them together. When you add them together, you get your answer. Remember, it's called molecular mass because atoms come together. Atoms come together to form molecules. So when the atomic masses come together, they're going to give you a molecular mass. So now, the relative molecular mass, like I said, is mass numbers. Now, hydrogen has a mass number of 1. Sulfur has a mass number of 32. And oxygen has a mass number of 16. I told you mass number are almost at times 2. Why at times 2 of atomic numbers. Now, the hydrogen is 1, the sulfur is 32, and oxygen is 16. Now, let's take our solution. Let's solve. Now, they say it is a sum of the atomic mass. Now, if you check hydrogen, hydrogen has 2 atoms. Sulfur has 1, and oxygen has 4. Oxygen has 4. So you have to sum every single molecule or element. Okay? It is being done by calculating each element. You don't calculate it as a compound. You bring out each element and add them to their atomic numbers. You bring out each mass number of each element and add them to the atomic numbers. Now, in essence, now you can see hydrogen has 2. The hydrogen has 2, but the mass number of hydrogen is 1. So like I said, you must have to times the atomic numbers, the number of atoms by the mass number to give you the molecular mass. You calculate, you times the number of atoms by the mass number, add all, and it will give you the molecular mass. Now, hydrogen there has 2. And the mass number of hydrogen is 1. So it will be 2 times H, 1 times S, and 4 times 16. And 4 times O, which is oxygen. Now, this 2 times H will be 2 times 1, because hydrogen has a mass number of 1, plus 1 times S. Okay? It is 1 there. So 1 times S plus 1 times 32 plus 4 times O. 4 times O is 4 times 16. Now, this 2 times 1 is 2 plus 32 plus 16 times 4. 6 times 4 is 24. Carry 2. 4 times 1 is 4. Plus 5 is 64. So plus 64. So 2 plus 32 is 34 plus 64. So it will be 2 plus 32 is 34 plus 64. So it will be 64 plus 34, and the answer is 98. That is our answer. The answer is 98. So the molecular mass of sulfuric acid, or the molecular mass of H subscript 2 SO4 is 98. It's very simple. It's very simple. 2 times 1, 2 times the mass number, 1 times the mass number, and 4 times the mass number. I told you it's the sum of the relative atomic masses. So in essence, you add the whole masses of the atoms in the compound, and it gives you the molecular mass. Now, let's go difference between atomic mass and molecular mass. The atomic mass corresponds to the mass of an element, while the molecular mass corresponds to the mass of a chemical compound. Okay? The atomic mass is just the element alone. The atomic mass talks about the element because it talks about atoms. Atoms are not found in compounds. When they make their transformation, they become molecules. When they make that transformation, they become molecules. Why? Because the elements react with other elements. In essence, atoms will react with atom, and it will give you a molecule in a compound. Why the molecular mass corresponds to the mass of a chemical compound. Okay? Now, as you can see, the molecular mass is given to us as the full compound. We added the whole elements in the compound. We added the whole elements. In essence, we added the whole atomic masses, and it gave us the molecular mass, which is 98. Now, similarity. They both correspond to atoms in an element. Yes, they both correspond to atoms in an element. Calculation of atomic mass deals with elements. Calculation of atomic relative molecular mass deals with elements. Why? Because you calculate the elements, mass number, and its atomic number together to give you the molecular mass. Now, all these things are being done because we know that moles, let's go to moles. A mole is the Avogadro's number of a substance. A mole is Avogadro's number of a substance. And the Avogadro's number of a substance is 6.02 times 10 raised to the power 23. That is the mole. In essence, it is the number of particles in a compound. The substance there can be a compound or an element. The substance there is a compound or an element. Remember, we talked about pure substances. So the Avogadro's number of a pure substance is a mole. It is the number of particles of that substance. The number of things that are being made of that substance. That is the number. So the substance is either a compound or an element. So the Avogadro's number is the mole is the Avogadro's number of either a compound or an element. Now, let's take molar mass and molar weight. Let's calculate, before the molar mass and molar weight, let's take some questions from moles. Let's take some questions and solve from moles. Let's take some questions and solve in moles. Moles. Now, they say, what is the mass of 4 moles of nitrogen? What? Okay, before then, let's talk about the molar mass and weight. Okay, the molar mass is the sum of the total mass in grams of the atoms present to make up a molecule per mole. To make up a molecule per mole. The sum of the total mass in grams of the atoms present to make up a molecule per mole. Okay, but before then, let's see some questions in moles. Like I said, let's see some questions in moles before we can talk about molar mass. Moles. Moles. Let's see some questions in moles. Now, they said, what is the mass of 4 moles of nitrogen gas? What is the mass of 4 moles of nitrogen gas? Nitrogen gas. Nitrogen gas. Now, remember, and they said 4 moles of nitrogen gas, and they said N is 14. In essence, the mass number of nitrogen is 14. Now, the mass, first of all, you calculate the mass of 1 mole before you can calculate the mass of 4 moles. So the number of particles present in nitrogen, like I told you, the Avogadro's mole is the Avogadro's number of a substance. In essence, the number of particles present in that substance. So in essence, the number of particles present in nitrogen gas is 2. That's the number of particles. If they wrote 3, then 3 is the number of particles. If they gave you 4 as the atomic number, then 4 is the particles. If they gave you 5, then 5 is the particles. Now, in essence, 1 mole of nitrogen gas will be equal to, like I said, the formulas are almost the same. It will be equal to 2, that's the number of particles, times the mass number. It will be 2 times the mass number. So 2 times 14 is 28. 2 times 14 is 28. Then 4 moles, so therefore 4 moles will be equal to 28 times 4. Very simple. 4 moles will be equal to 28 times 4. Remember, you've gotten 1 mole. When you get 1 mole, it's 28. You've gotten 1 mole, it's 28. So in that context, 4 moles will be 1 mole times 4. Will be 1 mole times 4. Now 28 times 4 will give you 4 times 8 is 48. Got it? 4. 4 times 2 is 8. 8 plus 4 is 12. So it will be 128. 128. 4 times, sorry. I made a mistake. Sorry, 28 times 4, 32. You carry 3. 4 times 2 is 8. 8 plus 3 is 11. So it's 112. Sorry, it's a mistake. So the answer is 112. So in essence, 100, the mass of 4 moles of nitrogen gas is 112 grams. 112 grams. Remember, SI unit for mass, we use grams because the SI unit for mass is kilogram. Okay? Now, the grams is smaller than the kilogram. Why? Because it is the particles. It is the, remember that we got a number of particles. So particles are small. That's why we use grams. Now, the next question for moles. The next question for moles, let's still run it down. The next question for moles says, how many atoms are there in 8 grams of oxygen? How many atoms? How many atoms are there in 8 grams of oxygen? In 8 grams of oxygen. And they gave you 1 mole, and they gave you 1 mole as 6.2 times 10^23. And O is 16. They gave you 6 times, okay, they gave you 6 times 10. They gave you 6 times 10, sorry. They gave 6 times 10, 1 mole as 6 times 10^23. And O is 16. Now, first of all, they said how many grams are there in 1 mole of oxygen? How many atoms are there in 8 grams of oxygen? Now, they gave you 1 mole as this, and oxygen as 16. In essence, 1 mole, okay, will give you 16 grams of oxygen. In essence, 1 mole will give you 16 grams of oxygen. So 1 mole, if first of all look for 1 mole, is equal to 16 grams of oxygen. 16 grams of oxygen. 1 mole is 16 grams of oxygen. So 8 grams of oxygen will be 8 divided by 16. Remember, they said how many atoms are there in 8 grams of oxygen? And they gave you 1 mole as 6 times 10^23. And oxygen is 16. In essence, the number of atoms that makes up 1 mole of oxygen is 16. The number of atoms that make up 1 mole of oxygen is 16. So in that context, 8 grams will be 8 divided by 16, which is equals to 1/2. Is equals to 1/2. Now, you've gotten the grams. You've gotten the grams of, you've gotten the grams now. Now, they said how many atoms are there in these 8 grams of oxygen? Now, you've gotten the 8 grams of oxygen as 1/2. You've gotten the 8 grams. Now, how do you get the number of atoms? How do you get the number of atoms? Getting the number of atoms is very easy. It's just, therefore, number of atoms will be equal to the mole. They gave you the mole as 6 times 10^23 divided by 2. Remember, half means divided by 2. So it will be 2 go into 6 is 3. So it will be 3 times 10^23. That is the number of moles. That is the number of moles, that number of atoms that are in. Now this becomes the Avogadro's number of this particular question. This becomes Avogadro's number. Why? Because of this 1023. This 10 to the power 23 makes it the Avogadro's number. Now, this is the number of particles that are present in 8 grams of oxygen. Remember, an atom is a particle. So take note. Now, like I said, we've come to molar mass and weight. Molar mass and weight is the sum of the total mass in grams of the atoms present to make up a molecule per mole. SI unit is grams per mole. Like I said, it's the sum of the total mass in grams of atoms present to make up a molecule per mole. To make up a molecule per mole. Now, the total mass in grams of atoms present in a molecule, in essence, present in compounds, the total mass, everything about this particular thing, everything about the molecule in grams becomes the molar mass or weight. Now let's take a question on molar mass or weight. Let's take questions on molar mass or weight. Now they say, what is the molar mass of sodium carbonate? What is the molar mass of sodium carbonate? Molar mass and weight. What is the molar mass of sodium carbonate? And they gave you Na as 23, C as 12, and O 16. They said it is a sum of the total mass in grams of atoms present to make up a molecule per mole. Is it the same thing? It's just the same thing. Okay? Now, for sodium, molar mass, we say Na is equal to 2 times 23 for sodium. C is equal to 1 times 12. And O substitute 3 is equal to 3 times 16. Remember, these formulas are the same. Why do we use 2? Because sodium is 2. It has 2 particles, 2 atoms. Why do we use 1? Because carbon is 1. No atomic number. Why do we use, no number of atoms? Why do we use 3 for oxygen times the mass number? It's because oxygen there is 3. So 2 times 23, 23 times 2, 6. 2 times 2 is 4. So 23 times 2 is 46. This is 12, and this is 48. And this is 48. So now, they said it is the sum of the total masses in grams. There's a sum of the total masses in grams. So therefore, molar mass will be equal to 46 plus 12 plus 48, all in gram per mole. That is the SI unit, all in grams per mole. So 46 plus 12 will give me 58. 58 plus 48, 6, will give me 106. So therefore, the molar mass is equal to 106 gram per mole. 106 grams per mole. That is the answer. 106 grams per mole. I guess you are following. Like I said, we use 2 times 23 here. The mass number of sodium is 23. Mass number of carbon is 12. And mass number of oxygen is 16. In these calculations, we do not use the atomic number as a point. What we use are the mass numbers. But if the element given has a subscript, if the element given has number of atoms, okay, you multiply the subscript by the mass number to get what you're looking for before you start doing your addition. You multiply the number of atoms present in the element by the mass number before you start doing your addition. Take note. Now, this is how it's been lined. 2 times 23, like I said, they multiply the number of atoms, which is 2 for sodium, 2 times 23. The carbon is 1 times the mass number. Oxygen is 3 times the mass number. It gives you 48, 12, and 46. The molar mass will be the addition. Like I said, it is a sum. It is a sum, okay? You sum all together, and it's going to give you this. Now, there is one, let's take another question on still this molar mass. One confusing question on still this molar mass. Now, they say, identify the molar mass of calcium nitrate. Identify the molar mass of calcium nitrate. Calcium nitrate, CaNO3. And they gave you Ca as 40, okay? N as 14, and O as 16. This one is somehow confusing, okay? Now, we are going to do the same rule, okay? Calculate the number of atoms present in the element by the mass number, okay? Now, for calcium, it is 1 times 40. For nitrogen, is the problem. It's not 1. For nitrogen, it's not 1. Why is it not 1? Because this nitrate, this formula for nitrate, this nitrate has the number of atoms inside. This nitrate has the number of atoms inside. In essence, this number of atoms too will affect what is inside this bracket, nitrate. This number of atoms too will affect what is inside this bracket. So in essence, if nitrogen is 1, and this 2 is affecting it inside, it will be 2 times nitrogen, which is 14. It will be 2 times nitrogen, which is 14. Now, for the ozone, which is O3, O subscript 3, the 2 will still affect it. Remember, this 2 is affecting only this thing in bracket. Why? Because the number of atoms present in this nitrate is 2. Nitrate already has the formula NO subscript 3. So the number of atoms in this nitrate, the 2 is affecting only what is inside the bracket. So anything that is inside the bracket will be affected by the 2. That is why I use nitrogen, which is 1, to multiply by 2. So 2 times 14, the mass number. Now, for the O subscript 3, it will be 2 times 3 for the oxygen. It will be 2 times 3. Why? Because this 2 is affecting what's inside the bracket. So the oxygen will be 2 times 3, which is 6. Then, in that context, the number of atoms present in this ozone or in this oxygen is now 6. Now it will be 6 times the mass number, which is 16. It will be 6 times the mass number, which is 16. Now, 1 times 40 is 40. 2 times 14 is 28. And 16 times 6, 2. Carry 3. 6 times 1 is 6. Plus 3 is 9. So 16 plus 1 is 92. So now when you sum all, it will be 10. You carry 1. 5 plus 2 is 7. 7 plus 9 is 16. So it will be 160. So therefore, molar mass is equal to 160 grams per mole. Remember, if you do not put this grams per mole, the answer is not correct. You must have to place each SI unit on every calculation you make. Otherwise, the answer will not be correct. If I say 106, 160, you do not know what I'm looking for. But if I put 160 grams per mole, you know I am looking for the molar mass of a substance. Like I said, I want to come again. These two affect what is inside this bracket. These two affect what is inside this bracket. So anytime you see this kind of question, you just know that the 2 is the number of atoms inside the bracket, the nitrate. So it's going to affect every single thing in the bracket. Now, rules for finding molar mass. We've done that already. Make use of the chemical formula to determine the atoms of each element. Multiply the subscript with the atomic mass of each element. Add up all the assigned units and grams per mole. We've done that already. Okay, we make use of the formula, chemical formulas, which is Ca, N, and OXO. Multiply the subscript with the atomic mass of each element. We multiply the subscripts with them. Okay, the subscript for calcium is 1. There's nothing there. The subscript for nitrogen is 1. Subscript for ozone is 2. So we calculated all, and it gave us the same answer. Now, mole ratio. When you get all these things, there is a ratio. Okay, mole ratio is the ratio between any two substances in a chemical reaction. Any two substances in a chemical reaction. Now, for example, any two ratio is something in a chemical reaction. Now, let's take mole ratio. Okay, let's say 2. Let's take 2 H subscript 2 gas, and we take O subscript 2 gas, and they gave us 2H2O gas. I know you're confused that you saw formula for water. I told you water can still be called dihydrogen oxide. Dihydrogen oxide. Dihydrogen oxide. Di means 2. Water can still be called dihydrogen oxide. But in this context, you have 2 molecules of water. And any molecule is not an atom again. So in essence, this becomes steam. This is the formula for steam. This is the formula for steam. Okay, vapor. Now, mole ratio. Mole ratio is the ratio between any two substances in a chemical reaction. The ratio at which these substances react together in a chemical reaction is called mole ratio. Okay? Why is it mole? Molecules. Like, take for example, water. Water has 2 hydrogen and oxygen. So it will be like 2:1. But let's see. Okay? They said, find the mole ratio of this. Now, find the mole ratio of this. Now, the mole ratio of 2H2 gas gives us, I know that this, you're surprised that you're seeing water as a gas. Yes, because this formula is the formula for steam, vapor. I told you water can still be called dihydrogen oxide. Di means 2. Okay, dihydrogen oxide can still be called water. So now when 2 molecules of water come to play, it becomes steam. It becomes steam. That's the formula for steam. Now, in essence, getting this ratio here, they say find the ratio of this. Okay, find the ratio of oxygen. Find the ratio of oxygen and water. Find the ratio of oxygen and water in this chemical reaction. Okay, in this chemical reaction. Now, if you check, they said that means to say, when you're looking at the mole ratio, you're to know that for every single 1 mole, for every 1 mole of oxygen, water is formed. For every 1 mole of oxygen, water is formed. And for every 2 moles of hydrogen, water is formed. Simple. So in essence, if you check 1 mole, this subscript here represents the number of atoms. Represent the number of atoms. I told you any number at the base of an element represents the number of atoms. But if the number is written together with the element, it becomes number of molecules. If the number is written together with the element, it becomes the number of molecules. So now, 2 molecules of water, of hydrogen, 4 molecules of hydrogen, that's 2 times 4, will react with this to give you this. So in essence, oxygen to water will be 1:2. If you check your oxygen is 1, and water here is 2 molecules. While hydrogen to water will be 2:2. Why? Because for every 2 molecules of hydrogen, water is formed. And for every 1 molecule of oxygen, water is formed. So in essence, for every 2 moles of hydrogen, remember these 2 here represent number of molecules. Or you can call it moles, 2 moles of hydrogen. Either 2 molecules of hydrogen or 2 moles of hydrogen. Either 1 molecule of oxygen or 1 mole of hydrogen. Either 2 molecules of water or 2 moles of water. Now, if you check, like I said, oxygen to water is 1:2. Okay? Hydrogen to water is 2:2. Why? Because hydrogen has 2 molecules, 2 moles. If the number, if the integer, if the coefficient is written together with the element, it's the number of moles in that element. Like I said, if it's written like this is 2 moles of hydrogen. This is 2 moles of hydrogen, or 2 molecules of hydrogen. If it's written like this is 2 atoms of hydrogen. I come to play. So, there is one thing I want to show you. So I guess you're understanding. There's one thing I want to show you in mole. It did not cross my mind. In that calculation is somewhat confusing. Okay? They said, how many moles are there in 20 grams? Moles. They said, how many moles are there in 20 grams of CaCO3? 20 grams of CaCO3. Calcium carbonate or limestone. They gave you Ca as 40. Okay, they gave you CaCO3. CaCO3 as 100. CaCO3 as 100. CaCO3 as 100. CaCO3 is 100 because the mass number of calcium, okay, is 100. The mass number of calcium is 40. Mass number of carbon is 12. It will give you 52. And the mass number of oxygen is 3 times 16, as we know, 48. It will give you 100. So that is why CaC3 is 100. They said, how many moles are there in 20 grams of calcium? Now, 100 grams gives you 1 mole. Why? The mass number in this context is the number of grams. The mass number is the number of grams. So they say 100 grams, they gave you this as this. So 100 grams solution, 100 grams of CaC subscript 3 will give you 1 mole. Why? Because the mass number of the compound becomes the number of grams. If they give you a question like this, the mass number of the compound becomes the number of grams. The mass number of the compound becomes the number of grams. If they give you a question like this that concerns the number of grams in a compound, the mass number of grams, the mass number of the compound becomes the number of grams. So in essence, 100 grams of this gives you 1 mole. So therefore, 20 grams will be equal to 20 divided by 100. 20 divided by 100 times 1 mole. 20 divided by 100 times 1 mole. If they give you 6 moles, it will be 20 divided by 6. If they give you 8 moles, it will be 20 divided by 100 by 8. So they said how many moles are there in 20 grams? It will be 20 divided by 100 times 1 mole, which is equal to 0.2 moles. That's the number of moles. That's the number of moles in 20 grams of this. That is the number of moles in 20 grams of this. That's the number of moles in 20 grams of calcium carbonate or limestone. Remember, I said if they give you a question like this, the mass number becomes the number of grams. The mass number becomes the number of grams. So 100 grams of calcium carbonate is 1 mole. Okay, any number they give to you, means the 100 grams of calcium carbonate is 1 mole. That's the number of particles that are present inside the compound. Now the 100 grams of calcium carbonate is 1 mole. Therefore, 20 grams will be 20 divided by 100 times 1 mole, which is 0.2 moles. If you don't want to put it times 1, you can still remove it. Don't put it times 1, you can still move it. So it is a very simple calculation. It is not hard. Thank you. We have come to the end of this section or of this lesson. Now, let's go to the exam guide question to quantify what we have learned from this lesson of today. Now, 2009, okay, 2009, question 16. It said the number of particles in 1 mole of a chemical compound is the. I told you that when we talk about moles, I defined a mole as the Avogadro's number of a substance. And I told you that substance is a compound or an element. And I told you the number of particles in a compound or an element. So in essence, they said the number of particles in 1 mole of a chemical compound is, in essence, the number of particles in the chemical compound, I told you, is the Avogadro's number. So the answer is B, Avogadro's number. Let's go to the next one. Let's go to the next one, 2014. 2014, question 10. The relative atomic mass of chlorine is not the whole number because I told you that it has 2 isotopes. Okay? I told you chlorine has 2 isotopes. But the atomic number is the same, but the mass number are different. If an element is written and there is a number down, the number at the down of the element represents the atomic number, while the number at the up represents the mass number. And I told you that chlorine has 2 isotopes. In essence, it has atoms with different mass number. And that is why the mass number is not a whole number. Okay, the mass number is not a whole number because I told you it's the average mass of all the isotope of the element. It's the average mass of every isotopes of the element. So that is the answer. It is the average mass of all isotopes of the element. Now, because of time, let's take the last question, which is 2002, question 1. If the relative molecular mass of an element is not a whole number, it can be deducted that the element is, I told you when I talked about chlorine. Okay, I told you when I talked about chlorine that the molecular mass of a whole number, if the molecular mass is not a whole number, okay, it becomes a mixture. it becomes a mixture, and that mixture is called isotopic mixture. Isotopic mixture, it becomes a mixture of different isotopes. In essence, it will give you the same mass numbers, the same atomic numbers, but the mass numbers are going to differ. Okay, the molecular mass numbers are going to differ. Why? Because some elements do not have a whole number as a mass number. So I told you that this is called an isotopic mixture. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.